Okay, everyone. So now what we're going to work on is looping through our file and testing, comparing the start station ID in each row to our desired start station ID. And then we're going to write that row to our file if it matches, and otherwise we're going to do nothing. Actually, we can just ignore it. So the first thing I'm going to do, of course, is I already have my go through line by line as my comment up here, and I'm going to say compare start station ID of current row to desired. I'm going to say 6A. If there's a match, write that row to my output file. And that's actually it, right? I can just write that row and then I don't have to do anything else otherwise. So the first part of this is how do I loop through this file? So there's something called a for loop. A for loop exists in basically every programming language. It is written slightly differently from language to language, but the concept is the same. Looping through lists of things is something we need to do a lot. So there is a construct for it, and quite simply, in this case, what I can say is the structure is for in. So I'm going to say for a row in this case, I'm going to use my City Bike reader because that's the thing that has collected. Okay, so hopefully you'll notice here is that the for and the in are in blue. Okay, this means that they are those special reserved words. They have a particular meaning in Python. The A row and City Bike reader are both variables. City Bike reader, of course, is the container, is the label of the container that contains my dictionary reader that I created from my source data file. What is A row? So A row is just a label for whatever the current row is. Okay, so this could be a little tricky to get our heads around at first, but basically what this is doing is it is constructing it is just giving us a place to put the label that for every time it goes to the next row is going to be in the box labeled A row. Okay, so the first time it's going to be it's going to be whatever the first, it'll actually probably be the field names row. And it'll say, okay, that's, whatever the first line is, that's what's in the box labeled A row. The next time it goes through the loop, then the contents of the second line of data are what is going to be in the box labeled A row. Okay, so this will make a little bit more sense hopefully when we go over in class if it's confusing, but basically, this is a very simple way that we can go through every single item in our list. Now, the other thing that happens when we do a for loop or a conditional, an if statement, which we'll do shortly as well, is that we have to indent, okay? And indent, so we've looked at ways, we've talked about sort of this idea of using parentheses or using curly braces, for example, in JSON as a way to kind of encompass things, to sort of bring them into a particular universe. In Python, this is done through the indent. So anything that is indented under this for statement is something that is going to happen for every single row in that file, okay? So in order to make sure that something happens every time, I have to indent it. When I outdent again, so to speak, right? When I go left justified again, that means that the for loop no longer applies, okay? And I have to do this in a coherent way, so I have to indent all of the things that I want to have happen under the for loop. When I outdent again, when I left justify again, it means the for loop is over, right? And in this scenario, I am not, by default, right, with this construction, that for loop is going to loop through every single line of data, okay? It's not like I'm going to say go through 100,000 and then stop. It's going to go through every single line of data. So anything that I want to happen to any line of data needs to be indented under that for loop. And then afterwards, I can do other things like, in this case, like close my files. Okay, so the next thing that I want to do, okay, so I've gone ahead and I've done this. I have said loop through each row in City Bike Reader. The current row will always be placed in, whoops, right in the box labeled a row. Okay, and so what that means is that when I come to my second part, or my next step, which is compare my start station ID to the compare the start station ID of the current row to the desired one, now I'm going to say, okay, if a row, because again, that's the label, for the current row, and then I can just put in here start station ID, so in quotes and in square brackets. Now, the reason why I have to do this in square brackets and quotes actually is precisely because there are spaces in these column headers. If there were not spaces, I could use a dot, the way they have with field names here, but because they've left spaces in them, I have to do this different construction. So again, this is one of the reasons why I generally discourage you from having spaces in things that you use as labels, just because it's extra stuff to type. It's handy to always be able to use that dot structure, but we don't have a choice in this case because we're not going to go through, I mean, we could go through and create new labels, but that would add extra work and probably some confusion to our output data. So now I'm going to say if the row's start station ID, and I want to compare it to my target here. So if you notice up here, when we use a regular equals sign, this is a way of saying put the stuff in the right into the box with the label that has the label on the left, right? That's how that construct works. So because equals is already being used to put data into a box, right? In most of our things, we call this assignment, right? Assigning a value to a variable, which is just a label. We need to use a different construct to actually do comparison. And in this case, and in most cases, in most programming language, that construct is a double equals sign. So double equals sign means compare these two values. Compare the value on the left to the value on the right. And in my case, I'm going to say 72. All of this data is going to be interpreted as strings at the moment. That's a safe way to do it. And so I'm just doing exactly what I said here, which is testing to see if it's 72. Now, let me say just here, I'm going to say write the current row to my output file. Okay. And here I am saying compare your current rows ID value to my target value. Okay. So I've done that, and in fact, I also want to put up here to desired, which in my case is 72. So I want to be explicit in my outline about what I'm actually looking for. The other thing to note here is that we have a colon at the end. So when we have a for loop or a conditional, which is that if statement, there's always going to be a colon at the end. And just as with the for loop, the way that I do that indent to say anything that is indented under this for loop is going to happen every single time every single row that we go through. The same thing here with the if statement. Anything that I want to happen only when that if statement is true, as in only when start station ID matches 72, I need to indent under that if statement. So this is where it gets a little bit tricky, or it's not tricky, but just we've worked with the field names row, right? And we were able to kind of work with that as a unit because it existed as this thing that the person who wrote that dictionary reader recipe in the CSV library decided there was just going to be this thing and it was going to contain the field names. For our purposes here, and also sort of looking ahead, we need to be able to manipulate the individual values in each row. And actually what this is hopefully makes sense, is that each row is of course itself a list of values, right? So we have each row is an item in a list that's in the dictionary reader, and then within each row there's a list of values, right, which represents the value for each column. So in order to write to our output file, we need to reconstruct each row, basically. And so to do that, what we're going to do is we're going to create a variable called, I'm going to call it new row in this case, okay? And my new row is just going to be an empty list. So you'll notice that the list syntax here is exactly the same as what we saw for JSON. It's those square brackets. And so by doing this, I've said, you know, create an empty box, label it new row, and in it put an empty list. There's nothing in the list right now. What I'm going to do here is I'm going to say, I'm actually going to create another loop. Okay, I know this gets kind of intense, but I'm going to create another loop where I go through all of the values in the row and add them one by one to this new row. And then the new row is actually the thing that I write. So I'm basically making a copy of the row. That's the short version, is I need to make a copy of this row. So I'm going to say create a new list to hold a copy of the current row. Okay. And now I'm able to, I use, again, it's exactly the same syntax. So in this case, instead of saying for every row in City Bike Reader, I'm going to say for a header and in this case, I'm actually looking at the field names, right? Because what I'm saying is go through that list of field names, that's trip duration, start station ID, et cetera, right? And for every header in that field names, I'm going to say new row, okay? And I have this function, this recipe, which is actually built into Python. It's very commonly used because we deal with lists of things a lot. Append, right? To append, it means basically, it means exactly what it means in English, which is add this to the end. Append the value that is currently in the current row, right? So the current row is a row, okay? And whatever is the current field name, which is a header. Okay, so again, I realize that this might be a little abstract right now. We'll go over this in class, kind of exactly what's happening here. But basically what I'm doing is I'm saying, look, I have a row, and for every header in that row, which is equivalent to trip duration, start station ID, et cetera, for every header in all of the headers, for each header in that list of headers, I want you to take this new empty list that I've created and add to the end the row that is in the value that appears in the current row under that header, right? So under trip duration, under start station ID. I mean, we know what start station ID is because we've done a test for it, you know, under start time, stop time, etc. Okay? And then once we have finished that, that's all that we're doing. Okay, so I'm going to say for every column header, right, in the list of column headers, add the value in the current row, or I should say append, because I'm not really adding it, not mathematically anyway. Append the value in the current row that appears under that header to my new row. Okay, so the moment I'm just going to check and see if I have any errors, and then we will go through, because I haven't actually written anything yet, right? I've gone through and I've constructed these new rows, but I haven't actually written anything to my output file. So there's quite a bit of work in getting to that writing to the output file, but it's just a couple of statements after this. Now, again, I've hit the command here and you'll notice that it's hanging. A lot of times we think hanging is bad news. In this case, hanging is not bad news because that blinking cursor means that it's doing work, right? It's busy. And when it's finished, it will return to this command prompt that says Python scripts, right? So that's something else that we need to get used to in these circumstances is that, again, no news is good news. If it's blinking, it's working, and we just have to wait for it to finish. All right, see you back here in a minute.